exponential derivatives. So the derivative we've looked at already is e to the x. And I told you the derivative of e to the x is e to the x. And I said, trust me. And I'll show you why soon. This is now why. Just so if y equals e to the x, then y prime equals e to the x. But why? So whenever you take the derivative of a number to an exponent, you're going to do this. E is just a number, right? It's just like pi. It's a non-repeating, non-terminating decimal. Okay? So whenever you have a number to an exponent, you're going to do this. And this is why it ends up just being e to the x. You're going to rewrite it. So when you find the derivative of that, you're going to rewrite it. Then you're going to take ln of the base. You always take ln of the base, ln. ln is just log base e. So log normally is log base 10. Whenever we just press the log button, that's log base 10, right? If we have another base, we'd have to use the base button, or we have to go log whatever divided by log 10, or log 2, or whatever the base is. Ln is just log base e. So they just made a button that you can press log base e instead of having to go log x divided by log e. So if they did it, this would be log e to the x is just ln x. So instead of them forcing you to write log x divided by log e, which is how you'd have to punch that into your calculator, right, if you didn't have the base button, they're just saying you can write ln x instead. Okay? So what do we do when we have a number to an exponent? We rewrite it. We do ln of the base, and then we write behind it the derivative of the exponent. The derivative of 1x is what? 1. Now, why does this just end up being e to the x? Well, e to the x is e to the x. Put ln and then e into your calculator. So press the ln button. Press the e button to the power of 1. Ln is second log. Or second, no, ln is right above log or below log. Somewhere near log. Ln is below log. E is behind ln. So second ln gets you e. If you're using the big calculators. Now remember, if you want to do ln of a number or something like that, you'd say to me, well, Mrs. Lepp, we need a calculator then. No. If it's ln 4, they'll leave the answer as ln 4, not the decimal. They don't want the decimal. They'll leave it as ln 4. You absolutely do not need a calculator. Okay? You will leave your answer as ln 4. You'll leave your answer as ln 5. So what is ln of e? 1. So ln e turns into a 1, and then I have a 1 behind it. What's e to the x times 1 times 1? E to the x. So the derivative of e to the x is e to the x because the other things cancel off. Okay? Now, what if I changed it, though, to be y equals e to the 2x? What happens if I change that? Instead of it being just an x, I made it be a 2x. Well, then technically what you would do when you get the derivative is you'd rewrite it. Ln e. And then the derivative of 2x, which is 2. What happens with that ln e? It's just a 1, right? So your answer will be 2e to the 2x. And kind of. Yes, but only with an e. Because if it was like 4 to the 2x, this would stay ln 4, right? It doesn't go away. It's only e that becomes 1. So let's try one like this. Y equals e to the 6x squared plus 2x. Not all that hard. It's just a little different. So try that one out. What would you do? You would rewrite it. You'd multiply it by ln of the base, so ln of e. Ln of e just happens to be a 1. And then the derivative of the exponent. So it's going to be 12x plus 2. Remember I told you if you can't do power rule, you're not going to be able to do any other derivatives because product rule uses power rule, quotient rule uses power rule, chain rule. Derivatives of exponentials uses power rule. So then we'd be left with y prime equals 12x plus 2 e to the 6x squared plus 2x. Yeah, ln e is just 1 when you plug it into your calculator. And the reason why that is this. Think about it. We don't even need our calculator to prove that. Ln e, ln is just log base e, correct? I told you that. So log base e to the e. What happens when we have that? That's just log e divided by what? Log e. That's why e to the 1 would just be 1. That's the reason why it works. Everyone memorizes that if you have those the same, that whatever the exponent is what it is. It's true. But the reason why is when you actually calculate this log e to base e is you're actually doing this. Log e divided by log e is just 1. That's the reason why it is. In order to actually type that into your calculator, if you didn't have the log base button, you'd have to divide it by the log. Okay. Now what happens if it's not an e? The ln just doesn't go away. That's it. So y equals 4x. So now instead of an e, I have a 4. Same question as I started with. The first question I started with was e to the x. But now I'm doing 4 to the x, correct? So what's the derivative of that? Rewrite it. So this is whenever your base is a number and your exponent is a variable. Everything we've dealt with so far, your exponent has always been a number. It may have been a half, like, or whatever, but you haven't ever raised, and it could be a variable. We've dealt with variable exponents before. We've had x squared. But what we have always done is we've always had like polynomials, right? So we've had to a fraction. We've had it to anything like that. But we've never had it where our variable is an exponent. When our variable is an exponent like this, when we have a number to an exponent, we have to do this every single time. So when our exponent is a variable, we have to do this every single time. So we rewrite it. We multiply it by ln of the base. The base this time is 4. And then the derivative of x is 1. So remember e to the x, it was just e to the x because e to the x rewrote it. Ln e became 1 and the derivative was a 1. The difference here is this isn't e to the x now, it's 4 to the x. Ln 4 doesn't go away. Ln 4 is a crazy decimal. We're not going to write the crazy decimal. We're going to write ln 4. At any point in time, would I actually need a calculator? At any point in time for this, would I need a calculator? No. Derivative of x. Because you always multiply by the derivative of the exponent at the very end. So you rewrite it, ln of the base times by the derivative of the exponent. Every single time. Okay. Y equals 4 to the 12x squared plus 3x plus 7. Do the derivative of that. So y prime equals, rewrite it, 4 to the 2x squared plus 3x plus 7 times ln the base, ln 4, times the derivative of the exponent. So drop the 2, you get 24x plus 3. You could just leave it like that. Now, this itself isn't bad, right? Just follow the same rules. The catch is that everyone forgets. They're like, oh, what do I do? So they try and like, I often find people will write this as 4 to the power rule. They don't rewrite it as like the actual exponent. You just rewrite it, ln of the base, multiply by the derivative of the exponent. Yeah. Why would you ever want to do that? No, and they're not the same base. You can only add exponents when you have the same base, right? But even if you did have the same base, why would you want to put those together? That is just that. This is simplest form. What? Oh gosh, no. Oh gosh, no. Because it doesn't work. Because you can't do power rule when your variable's an exponent. We've only ever done power rule when your variable's a number. The moment you have an exponent that is a variable, you have to do this. Like everything we've done so far would be square root of x, blah, 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 but they're all to a 2 or a half or -3 or something, right? They've never been to an x. So what if I give you this? This is the one that encompasses trig and exponential. So differentiate. Because remember, we learn these separate rules, but then we can put them together with power rule or product rule, right? They can encompass all of them together, however they want. So differentiate. F of x equals 2x, and then we'll go times sine ex, e to the x. 2x times sine e to the x. Try it out. F, G, F prime is 2, G prime is the derivative of sine is cos. Rewrite the inside bracket. And then you have to do the derivative of the inside, which is e to the x. So you're going to get f prime of x equals f times g prime plus g times f prime. Now I can take a 2 out of all of them, so I'm going to get a 2, and then I'm going to be left with x e to the x cos e to the x. Now I could write this in 3 different ways, right? It doesn't matter. This is just usually they write the trig last, but you wouldn't be wrong if you wrote them the other way. Plus sine e to the x.